yeah. Uh,
Yeah, yeah. So yeah,
uh,
very, very good questions. Very interesting questions. Yeah.
Mm. Yeah, so I will just give here one line description. I mean, one line of your your
Mhm.
introduction, and then I would request you to introduce yourself. So as I know you, I will I mean put the introduction in that part. Like you are head chief scientist at Uniphore, and you were the director of engineering at for Google Assistant, and you were
Mhm.
also leading I mean you were also director of engineering at Jibo, so you are kind of a true industry veteran in the sense
Yeah,
of
yeah,
like speech recognition, and you wrote the
yeah.
book Voice in Machine, so you are the true
Two
industry
books. Yeah, yeah. Two books. Yeah,
in this speech
yeah.
recognition field. So yeah, why don't you introduce in your words?
Okay. Yes. Thank you, Prita. That was a really good introduction. We met while you were at Google. We have some work together, and yes, I've been in AI. I say for more than 40 years. And I started in speech recognition many, many years ago when I was in Italy. And then I went to Bell Labs. I continue speech recognition, and then I moved into natural language processing, natural language understanding, and dialogue systems, reinforcement learning for dialogue, and so on. And went, be, I was always between research and products and development. My last gigs, you said, about Jibo, which is an amazing, amazing product. It was a robot, and then Google in Zurich first, and then New York, and now Uniphore, where I'm the chief scientist. And we exploit generative AI for enterprise applications. This is in brief, a short story. It just skipped many parts there, but yes, that's a brief story of my career. Yeah,
Yes. So I'd like I mean should we start with the questions?
sure. Yeah, I'm
Yeah.
ready. Yeah,
Yeah, so my first question, since you were into like from long back, like since you were into this field of natural language understanding, and then you were into Jibo, Google. So I'd like to understand the brittle nature of intent. So basically, the early work was where there was structured slot filing and frame-based NLUs. There were bag of words, and all of those things were very structured.
Mhm.
And now, from this Google Assistant and newer version of this virtual assistants are moving towards generative LLMs, and there are like unstructured understanding, right? So,
Mhm.
how this is? I mean, according to your opinion, is it like making the assistant more helpful, and as well as is it also making their failures more unpredictable? How you
Yeah.
explain these things?
Yeah, yeah, thanks a lot. It's a very good question and gets right to the core of the evolution of the past decade. I I try to expand a little bit more on the assistant. I mean, saying that it was just based on intent is an oversimplification, and also because the assistant was doing many things. I was doing things for the user. You can say play music or set an alarm or what's the weather or whatever, and then was having a chit chat. We called it personality in Google. So you could ask, "How old are you?" to the assistant, or "What do you think about Google?" and all these type of things. And you can have search, right? You can say, "When when was Mozart born? When did Mozart die?" and so on. That require the bigger search. And every one of these three activities, so actions, chit chat, and search, use different ways to accomplish that. And the intent was mostly related to the action pattern. Why? Because eventually, when you ask for an action, you need to go and call a specific API to execute the action. So whether it is setting an alarm or asking for the weather or other things, right? Yeah, they're APIs, and you need to feed data into the API. So the intent was a very good way to I see that as a funnel, convey many different ways to say the same thing into a single request, AI API request. So At that time, we didn't have many other ways to do that. And it was to quantify all the actions that we could do into intent. The other way, the chit chat did not use intents, use the different technologies, and search use a lot of different things. Uses search, the classic search, and knowledge-based search, and other things. So the intent is mostly for the action part, and we did a lot of activity in crafting these intents. We had intent schemas, right? So if you ask for setting an alarm, you need to have for instance, as a minimum a time, right? And so on, right? Now there was a lot of work, the large teams, and crafting intents and making sure that the whatever you say was classified in one intent. And we use classifiers, right? Now with LLMs, a lot of things change because there is not a specific description, I think the definition of intents is more like you said, is more like implicit instead. So LLMs like Gemini, for instance, can respond to questions and can have chit chat, can have search and other things. Uh, for the action part, we need to do specific things for LLM to be able to call an API, to invoke an API with the right parameters. And
Mhm.
that's different than what we used to do. Now, the what we traded at the time is uh, uh, observability and debuggability, because at the time of intents, it was easy to understand why something failed because the intent was classified incorrectly. And so now it's a little bit more, it's not impossible, but it's a little bit more complex, right? We still gain a lot from the part of the LLM that translates whatever you say into something actionable. At the time, we used the classifiers and we had to do a classification for any particular intent. Now, LLM comes already pre-trained and you can do a lot of good things. So, in a way, we trade the flexibility of the LLM for the observability and debuggability that we had with intent. And I believe altogether is a positive thing that we can do much more. The LLM is always able to respond. Now, there are issues there. There are, many people know about hallucinations, for instance, and also the inherent stochasticity of LLM that come from different reasons, not just for the fact that we use statistical weights and stuff like that, but also from other issues inherent to the inference. Yeah. So I hope I answered your question.
Yeah, so is it like they are complementing each other?
Exactly, exactly. I saw, but today I think we abandoned most of the intent based things. But that what we didn't have at the time is this flexibility of whatever you say can be interpreted eventually. At the time, we had a lot of failures for that. Yeah.
Sure, sure. Thanks a lot, Roberto, for this explanation. So, my next question will be, since you were into social robotics for a long time, and Jibo was a social robot, basically, it had this head nodding and all of these features. So, I wanted to understand how you experience, or what is your opinion on the uncanny valley of social robotics? Like,
Mhm.
is it like, I was going reading through that, like uncanny valley is some psychological uneasiness with a robot if it is becoming too human, but because it cannot also become too human because it sometimes have dead eyes and unnatural reactions with some humanly, like too human answers. So how do we how you suggest to overcome that issue, or it should not be an issue at all if it is useful? And
Yeah.
also with that, I would like to understand what is the difference between Jibo, Google Assistant, and Google Home. Basically, there was a that one also, Alexa, technically.
Yeah. Okay. Okay. Well, a lot of questions, but very good questions. Thanks, Prita. So Jibo was my it was a defining moment in my career, although Jibo the company didn't succeed the way we wanted. But the way I say it, we didn't design Jibo for transactions. We designed Jibo for relationship. And when you cross that invisible line, you get you experience something that we couldn't even predict. The the fact that users of Jibo, we had a quite number of enthusiasts that bought Jibo and they use it daily. When you cross that line of going from transactional to relationship, people bond. People bond with the technology. It's what that goes called the Tamagotchi effect. Many years ago, probably before your time, you were not even born. There was a little thing called Tamagotchi that was a very, very cheap device, and my kids play with it. You had to feed it, and I remember children were devastated when they didn't feed it enough, and the Tamagotchi, the software thing, died in a way, right? So it elicit emotions and feeling, and the Jibo did that. Now, we talked a lot at Jibo about the Uncanny Valley. And Uncanny Valley is this phenomenon by which the closer you get to similarity to humans, uh, the more scary because think about a robotic arm doing some industrial things is not scary, right? But a zombie looks like a human, but it's almost quite not a human. And so this is the uncanny valley. So at Jibo, we decided consciously to make a non-anthropomorphic robot. Jibo has, a little head, one eye that morphs into these drawings and little things, and people loved it. People really loved Jibo, and so it also demonstrates two things. We are far from the uncanny valley with something like Jibo, and also how bonding, emotionally bonding with something doesn't have to be necessarily human-like. You can bond with an entity that it doesn't resemble human, but it has some social cues. The voice, the prosody of the voice, and the movement that Jibo was making were eliciting social behavior and triggering social cues of cuteness, of bonding, and stuff that have been studied by many scholars, like going back to the 1980s. Nass and Reeves, two psychologists of Stanford, that wrote this book called The Media Equation. It talks about when are certain social cues that a computer can have can trigger our behavior, and we behave with computer in the same way we behave with human. Now, the interesting thing about human is you ask about the difference between Alexa and Google and the assistants in general, Siri, uh, and Jibo. Jibo was designed for relationship, designed to. But there are two elements here. There is a transactional part and the relationship part, and we cannot confuse the two. So when we asked Jibo for setting an alarm or for the weather in New York, we wanted a precise answer, a correct answer, right? And but then we could also have a kind of more relational thing, asking Jibo, "How are you doing today? Are you a boy or a girl?" Or this type of thing. So the two things cannot be confused because uh, uh, transactional, the accuracy of transaction elicits trust. So if I have a machine that never sets the correct alarm, that never gives me the correct weather, I lose trust in this machine. Like a human, I lose trust if I work with a human that gives me incorrect information. The relationships part is very important because very often we humans really don't know what we want, right? It's not, we are not an API. There is not API. Human API say, do that. Sometimes we don't understand things. We don't understand what is the right answer to a question. And that's where many speech recognition applications have corrections, have uh, specification of the request, and so on. And that moves slowly into the more emotional relationship part. So this is there is one other thing I want to say about there are many people today many customers ask for, I want a more human interface. They don't even know why. An ATM is not human, right? But we trust it 100%. It never happened to me that I got the wrong amount of money. Never in my life, right? So I trust an ATM 100%. And I don't need an ATM to be human for me. Yeah, like people say, do you need a tool like a hammer to be human? To be no, we don't need it, right? A tool is a tool is a tool, right? So when we move to more towards AI assistance, there is a part that could help the user understand what they want, could help the user refine their request, or do other things that a simple transactional interface doesn't.
Yeah, nice. That is really insightful. Roberto, my next question will be, and it is also referencing your book, Voice in the Machine. I wanted to understand about Turing test for this speech assistant things, right? Is it like what should be the goal of this speech recognition technology and virtual assistant, like mimicking the human or doing something for human, or human likeliness should be their goal? If you elaborate on that part.
That's a nice follow-up from the previous question. We talk about human likeness. And I say there are many people uh, they want human-like interfaces, and they don't even know why. And there's a big risk in human that working in speech recognition for many years, I encountered that discussions many times. Should we make our interface more human or less human? The risk in making interface more human is that users may believe that actually the capabilities of the interface are human-like. And so they get very disappointed when it fails. So we always try to find a midway, right, between being human but not too human, to suggest that the system, especially before LLMs, before generative AI, they, we didn't want to suggest that it could do anything, right? Could do. Yeah. So today we're moving towards an AI that can really do much more than we could do now. What we want, why we want to have it human, is a big question that is not. I don't have a clear answer to that question, right? Because there are no experiments and no scientific evidence that having a more human interface goes helps the interface to behave in a better way and to perform transactions in a better way. So, to answer your questions, I believe that, as I said before, there is the trust of the transactional part, the accuracy. We need to make sure that transactions are executed accurately, right? Yeah. So, I think the human.
uh Roberto, I lost you. Your Just a second. Think-
Hi, am I audible?
Oh yeah,
Yeah, I think
yeah.
some issues happened with my headphone. So, yeah, we
Okay.
continue
Sorry.
the
Yeah.
topic. Mhm.
So let me see. Let me reconnect. Okay, you can hear me, right?
Yes, yes, yeah.
So okay. Um, yeah, I hope I answered your question. I don't know if or maybe we can do it again to re-record
Uh,
it. I don't know.
I could hear it almost. So just summarizing. So I think your point is like to make it more human or more trustable. That is still a kind of a area where basically the research is going on, right?
Exactly. And except for, I see a lot of people requesting, oh, I want the interface to be more human. And I will ask them why, right? And you want the interface to be trusted, and then you need accuracy, you need and you need understanding what the user want in a better way and executing that. That's the main goal. Yeah.
Yeah, yeah. So my fourth question will be a little bit imaginary. So I was just thinking, like previously it was only text-based language model. Then now
Mhm.
these tools and assistants support the speech recognition, image recognition. So is there any like research going on for smell recognition or taste recognition? Anything on that?
Yeah. There are three senses that we never use. We use the like haptic, touch, right, and smell and taste. Haptic has been there's a lot of research there. Robotics, especially in industrial environment, need to have the sense of touch, need to touch the material that they're working with. Yeah, so there is a lot of work there, and even robotic hand need to to grab something and make sure that they don't break the thing, right? They need to have the kind of
Mm.
sensibility like in the fingers or whatever, like we have human. The smell, I know that there are some work in smell, we are not quite there in smell and taste. I don't even know that. The only application I can find is to build an assistant that is a wine taster, right? Imagine you talk to an assistant talking about wines or food, right? So you can, but I don't think uh, we will get there anytime soon, in my opinion. I might be proven wrong, but smell and taste and haptic, I think so. I think that the touch will be something that we will get sometime soon. So and also it's very difficult, right? While to a certain extent text is quite clear, we can see words written. Voice is a little bit less clear, right? Because we have different accent, a different way to express the same thing, different intonation and stuff. For smell and touch and taste, there is not agreed upon you know, quantization of the stimuli, right? We might disagree. Oh, this is salty, this is sugary, right? Or so sweet, or this is umami, right? There are many different, and the boundaries are not very clear. So I think that is an interesting to think about that, and I'm sure there are a lot of academics working on that, but I believe it's a little bit far from the
Yeah,
production path. Yeah.
yeah. So now coming to privacy latency paradox. So all of with these assistants and all, we are giving our data, our day-to-day conversations and everything. So how we ensure the on-device privacy, that data is staying at local and no
Mm.
hack has been done. And then again, the good recommendation without hallucination, latency of the conversation. So this paradox, how actually the researchers are trying to solve.
So practically, you talk about three things: latency, privacy, and determinism. And today, there's exactly the three things that the big language models, generative AI, lack, right? And there are people working actively to improve, to reduce hallucination, to make it them more deterministic, to improve the latency and private. Privacy is still a very difficult thing. I think an extreme solution of that is to have what people call AI on the edge, to have AI running locally on the device with some guarantee that everything is resolved locally. These smartphones, they have the capability to run small language models. In fact, they do, right? Pixel phones, they have TPUs, and other phones, they have strong computational capabilities. And there we can see a lot of language models that are very tiny compared to the large one. Tiny, I mean like 1 or 2 billion parameters, right? It could fit on a device. Yeah. So that will solve or help solve the problem of privacy and latency also. And I would like to say that many today we tend to use or overuse LLMs for doing anything, right? Because we say, oh wow, we have this fantastic tool that can do a lot of things we were not able to do before. But many things we probably don't need an LLM. So I would say that there are people who are actively working in a direction where you can achieve more determinism by using LLMs in a more deterministic way. For instance, by creating code or using traditional code for doing simple things where we really don't need LLM. When I'm talking about the latency, of course, having things like solve the problem of latency. There is another important fact, right? That having a local LLM makes or a local intelligence, the cognitive intelligence doesn't have to be LLM. I stress the fact it does not have to be LLM. It could be something simpler for certain restricted tasks. This intelligence is closer to the sensors. So imagine we're talking about robotic arms, right? Imagine that I have a robotic arm that needs to find defects on a surface or something like that. And there are sensors on the robotic arm that touch the surface. If I had to send this sensor signals to the cloud and back and tell the arm to do something, it takes a second or a bunch of seconds, right? If I could develop AI directly in the arm, in the device, I could react immediately. So there are many situations we want zero latency or very, very tiny latency. And the proximity of sensors would help a lot. Yeah. So I think we're going to see a lot of that in the coming years. More bringing back AI to the edge and to devices and reduce the dependency on the cloud.
Sure, sure. So my last question will be, Roberto, what are your suggestions to the AI enthusiast or new AI
Of
engineers? Maybe?
of course, yeah. So my suggestion would be to study the history. Yeah, and you see a big difference. You see a big difference in students, practitioners, and even high leaders, right? They don't know their history. They believe that AI was invented 3 years ago, and they don't know that there's been 50 or more years,
Yeah.
or actually 70 years, if you want to be precise, right? The
Mhm.
history, the winters of AI, and going from the good old, the Go-Fi, the good old AI to statistical. People don't even know about the statistical machines that we built, and they actually, what they brought solely towards today's transformers and to the future evolutions of that. Yeah. So I think study the history, be humble, and don't think that everything you see now is it's new. People have been thinking about that for decades. And approach the field with humbleness. That's an important thing. There is the epistemic humbleness that characterize the smart people, characterize the smart researchers, as opposed to what's called epistemic closure. Say, oh, I'm right, you're all wrong because I know it. Yeah. So the humbleness is an important thing of of researchers and scientists and even technologists.
Yeah, yeah, that is really necessary. That is really interesting also to know about the history, like how from Stone Age to the Silicon Valley, everything is going on.
Yeah,
And
exactly,
that is
exactly.
also kind of my inspiration to this podcast sessions, because I think, like,
Mm.
talking to the technology researchers gives an immense amount of knowledge, like, how things started and changed, like, along the years. So that's really great. So thank you, Roberto. I have completed all of my questions, and thanks a lot for coming to my podcast. Any question you have?
No, I think, yeah, a question for you. What are you going to be more and more involved in AI in your future? You see that in your future?
Actually, I am planning to. I'm trying to also. So
Mm.
yeah, so that is the thing. So
Mm.
just a second.